Hi dear friends, I am Bhauseb Sonone, Assistant Professor, Department of Chemistry, Gokhale Education Society's Arts, Commerce and Science College, Jawar, District Palagar. Dear friends, in the last part of this lecture series, online lecture series, we discussed an important topic in the last part entitled as nuclear reactor, how we can convert nuclear energy or how can we obtain nuclear energy in controlled manner in the device, and that device is called as the nuclear reactor. Dear friends, if you really remember about the last part, if you have gone through the last part of the video, then you might be remember about the various components, essential components of that nuclear reactor. Before discussing the next part, today I want to revise the various important components of the nuclear reactor, and then, dear friends, we will proceed for the discussion of the next topic, which is also based upon the same nuclear reactor. Friends, already in the last part we discussed about the nuclear reactor and how we can obtain nuclear energy in controlled manner with the help of this device, and that's why whenever we want to define the nuclear reactor, it is a simply device in which nuclear energy due to fusion of nucleus or the fusion of nuclei is obtained in a controlled manner. Dear friends, this term is very important in controlled manner. If any nuclear reaction is not carried out in controlled manner, then definitely the same nuclear reaction can be very dangerous. And you know very well, in the last part we discussed that this whenever the nuclear reaction, actually with nuclear reaction is a chain reaction, because the number of neutrons obtained or the neutrons obtained in one fusion, these are responsible for the fusion of other nuclei, and that's why their number must be controlled. And once their number is controlled, then that chain reaction or the nuclear reaction can be also controlled. So it's very simple that the device in which nuclear energy is obtained due to nuclear fusion in controlled manner, then that device is called as the nuclear reactor. Friends, if you remember about the various important parts of the nuclear reactor without which it is not possible to obtain the nuclear energy, the essential part, you know very well, the first part is called as the neutron source. So we are requiring the slow neutron, and the source of neutron is simply nuclear fusion in which the first neutrons are obtained. Again, that can be converted into slow neutron, and this slow neutron is having energy 0.025 millielectron volt, and that's why these neutrons are called as thermal neutrons. So thermal neutrons are the source of, are responsible for the nuclear fusion, and that's why we are requiring the source of neutron also. Again, these neutrons are bombarded on the target material or the nuclear fuel or the material which is responsible for the fusion, which is going to be undergo fusion, and definitely this target material which is bombarded by slow neutron is called as a nuclear fuel. Dear friends, if you remember about the types of nuclear fuel, then we are having the two types of the nuclear fuel. One is called as the fissile material and another one is called as a fertile material. Definitely one fissile material undergoes fusion directly, producing large amount of energy with the liberation of neutron, while fertile material itself non-feasible, but it can be converted into feasible material. The third important part, which is the central part of the nuclear reactor in which the nuclear fuel is placed, and that central part is called as the core. Definitely it's one of the important part of the nuclear reactor in which the nuclear fusion is going to take place, and that central part in which the nuclear fuel is placed is called as the core. Again, in order to convert the fast neutrons which is obtained in the nuclear fission. So these fast neutrons can be converted into slow neutron because we are requiring the slow neutron for the next nuclear fission of the another nuclei, and that is done with the help of material called as the moderator. So these moderators are the material which can convert fast neutron into slow neutron. Next important component is called as control rod. So number of neutrons in any nuclear reaction must be controlled, and these are absorbed by the rods, particularly cadmium and steel alloy rods, and these rods which are responsible to control the number of neutrons are called as control rods. Next, the excessive amount of energy is liberated in the form of heat, and this heat is removed by the substances called as a coolant. So here either ordinary water or deuterated water can be considered as the coolant, very well. So next component which is also the important called as neutron reflector. So in order to prevent the escape of neutron from the surface of the nuclear fuel, again some substances or the particular layer is used, and that substances are called as neutron reflector. So these are used to avoid the escape of neutron from the surface of the nuclear fuel. And the last one, in order to prevent the leakage of radiation out of this nuclear reactor or the core of the nuclear reactor, it is surrounded by means of a particular material, particularly sheets of the lead, and these are called as shielding. Dear friends, I just tried to revise this, revise about the nuclear reactor and its main important components. These are nothing but 7 to 8 components which are the essential parts of the nuclear reactor. Because based upon the same, we are going to discuss the next topic or the next part, which is also based upon the nuclear reactor, because the components of the nuclear reactor and the whatever device that we are going to discuss, these are not different. And the next part that we are going to discuss is called as the before going to discuss whatever component that we discussed, these are called as neutron source, nuclear fuel, core, moderator, control rods, coolant, neutron reflector, and last one is the shielding. So how these are arranged or how these are connected to one another to form this device called as nuclear reactor, that we can see with the help of this diagram here. So I will try to show you this diagram. So this diagram indicates this is the systematic diagram, diagrammatic representation for the nuclear reactor. Dear friends, so this is the source. I hope you will be able to see here all the part that we already discussed in the previous part and revised in this part of the video. So here this is the source. Actually, this is the source, and this is the systematic representation of nuclear reactor. So this is the source. So source in the sense we are requiring neutron source. So this is the first part. Again, this the core part of this nuclear reactor containing the nuclear fuel. So this is the core, which is the central part of the nuclear reactor, in which the nuclear fuel, either fissile or the fertile material, is placed. So this is the core of the nuclear reactor. Again, the number of neutrons in the nuclear fission is controlled by means of a material called as a control rod. So here, in order to control the number of neutron in any nuclear reaction, the rods, particular alloys, are used. These are called as the control rods. Okay, so these are the control rods. And again, in order to prevent the leakage of radiation out of the central part of the nuclear reactor, that we call it as the core, it is surrounded by means of thick sheets of the lead, and this we call it as the shielding. So this is the shielding. I hope you can understood about this. And again, moderator, these are the materials or the substances which are responsible to convert fast neutrons into slow neutron, and that substances or the materials are called as the moderator. These are the substances which can convert fast neutron into slow neutron, because the fast neutrons are formed, these are obtained in the nuclear fission, and again these are required for the next nuclear fission. So these must be converted into slow neutron, because only slow neutrons are responsible for the nuclear fission, and these fast neutrons are converted into slow neutron with the help of substances called as the moderator. Next one is the excessive energy in the nuclear reactor is liberated, and that excessive energy of the nuclear reactor is liberated, or it is uh, obtained in the form of liberated in the form of heat, and this heat is removed with the help of substances, and these substances are called as a coolant. Again, we are also having the heat exchanger here. Later on, this heat exchange or this energy is transferred to the turbine. There it will be transferred to the generator. Definitely, this is the feed pump which is connected to this part, heat exchanger, in order to just control the heat. And this energy or the heat is transferred to the generator. There the generator is connected to the transformer, definitely, which is the next part of our discussion. So this is the actually nuclear energy which is converted into heat, and this heat will be transferred to the generator. There it will convert this heat into electrical energy, and this electrical energy will be transferred. So here simply the conversion is nuclear energy get converted into electrical energy, but here we are discussing this diagram only to obtain the nuclear energy in the nuclear fission or the nuclear reaction in controlled manner. So this is the diagrammatic representation of nuclear reactor. Dear friends, in the same thing, we can also discuss the another diagram of the nuclear reactor that will be more efficient for you, more convenient for you to understand this, because earlier was given in the textbook, and this I tried to obtain this from the resource from the Google. So here this diagram will helpful to understand how the systematic representation of nuclear reactor can be done. So here whatever part that we discussed in the previous part of the video, right now from the neutron source till the shielding, so all this can be studied, all this can be considered here. You can see here how these different parts are arranged. So this is the shielding, means this is the layer of the lead sheet which is responsible to prevent the leakage of the radiation out of this central part, that is called it as the concrete shielding or simply the shielding. Again the central part that we call it as the core, in which the nuclear fuel is placed. So this is called as the core. Okay, this is called as the core, which is the central part of the nuclear reactor in which the nuclear fuel is placed. Again, the number of neutrons in the nuclear reaction during the nuclear fission is controlled with the help of rod, particularly cadmium and steel alloys rod, and these rods are called as the control rods. Here it is labeled as the fuel rods. Again, this is thermal shielding. This is the layer which prevent the excess loss of excess heat. That's why it is called as the thermal shielding. Again, this heat is transferred through this coolant pump. Again, this is nuclear reactor coolant pump. It prevents the excessive loss of heat. Actually, it removes the excessive heat energy. Again, this steam generator, superheated steam. So it will be this nuclear energy will be converted into heat. So this superheated steam will be transferred to turbine, and turbine will be transferred to generator. So this is just like the previous one. There is nothing different between these. Dear friends, today, based upon the same, we are going to discuss the next or the same topic, just like the nuclear reactor. Nuclear reactor and power reactor is not too much different. You have to understand this. Actually, what is a nuclear reactor? Nuclear reactor is the device in which nuclear energy is obtained. Nuclear energy is obtained during nuclear fission in controlled manner. So, device in which nuclear energy is obtained is called as the nuclear reactor, and the device in which nuclear energy get converted into, or the nuclear energy is converted into electrical energy, that device is called as a power reactor. So I hope you can understand. So you can say that power reactor is the extension of nuclear reactor. because in the nuclear reactor we are obtaining the nuclear energy, and whenever this nuclear energy converted into electrical energy, then the same device can be called as the power reactor. So power reactor is the furnace in which fissionable material produces energy, means the nuclear material, in the form of heat, and that can be used to generate the electric power. So here definitely, here is the simply conversion is that here in this furnace simply the nuclear energy will be converted into steam or the heat, and later this heat will be converted into electrical energy or the electric power, and that's why this is called as the power reactor. So the essential components or the parts of the nuclear reactor will be as follows. Just like the nuclear reactor, there is nothing different between the central, we are requiring the central part, because power reactor and the nuclear reactor both are exactly same, nothing difference. Only power reactor is the extension of the nuclear reactor in which the nuclear energy will be converted into electric power through the steam or the heat. This is only the difference. That's why core, just like the nuclear reactor, here also the core is the central part in which the fissionable material is placed in the reactor, and that central part in which fissionable material is placed, that part is called as the core. You know very well there are two types of the fissionable material. One is called either, particularly in the power reactor, the two types of the materials can be used fissionable. The one is called as the uranium 235, and the another one is the plutonium 239. So these two types of the materials generally used in power reactor to obtain electric power or the electrical energy from nuclear fission. Next is the moderator. You know very well moderator. These are the materials which are responsible to convert fast neutrons into slow neutron. And in the power reactor, particularly heavy water, means the deuterated water or the graphites are used as a moderator, which are responsible to slow down the neutron, to slow down fast neutrons. Next is the control rod. Already we discussed about the control rod in the power reactor, in the nuclear reactor, but in the power reactor, the whatever control rods are used, these are made up of the cadmium or boron steel, and these are responsible to absorb the neutrons in this, particularly thermal neutrons, and these are responsible to maintain the multiplication factor K is equal to 1. Multiplication factor, you know very well, it is the ratio of number of neutrons in n plus nth generation to the number of neutrons in n minus 1 generation. So number of neutron in all successive generation will remains identical, then and then this K will be equal to 1. So here the number of neutron in one step will be equal to the number of neutron in the next step. If this number of neutrons are same or identical, then their ratio will be also same, that the ratio will be equal to 1, and this is possible by absorbing the thermal neutron in the nuclear fission, and this absorption takes place with the help of material, that materials are called as the control rods. So control rods are responsible to maintain or to control the nuclear reaction with the multiplication factor equal to 1. Next one is the coolant. You know very well, we already discussed the excessive heat in the nuclear reactor or the power reactor is removed with the help of material called as the coolant, and here the heavy water is used to remove the heat generated in the core or the central part of the reactor, power reactor or the nuclear reactor, due to fission process, and this material which removes the heat generated in the reactor is called as the coolant. Particularly this is during the nuclear fission in the core or in the central part of the nuclear reactor, and this excess heat or the heat generated in the core part of the reactor is removed with the help of material called as the coolant, and particularly heavy water is used for the same. So here we try to discuss all some parts of the power reactor. I am again repeating here, power reactor and nuclear reactor is not too much different from one another. Power reactor is the extension of the nuclear reactor, but difference only is that whenever we are obtaining energy in controlled manner, then the device obtaining nuclear energy in controlled manner during nuclear reaction, then the device is called as the nuclear reactor, and when this nuclear energy converted into the electric power or the electrical energy through the steam or the heat, then the device or the furnace is called as the power reactor. So this is nothing but important. So dear friends, today we just try to explain this power reactor, and in the next part of the video of this online lecture series, we will discuss how is the construction and working of this power reactor. So dear friends, in the next part of the video we will discuss about the construction and the working of power reactor, and also about the breeder reactor. So dear friends, we will resume again in the next part to discuss the next topic again on the same power reactor for its construction and the working. Thank you very much.